Yeah, so MoveByBike is a micro-logistics company that operates in Verona, serving mainly the core of the city center, which is quite inaccessible to cars. And that's why our client outsource their transport to us, because we are more convenient for them. The cargo bike industry for like a private citizen is doing quite okay. There are many models and they are reliable. The problem is for our usage, then it's a different story. We use scooter, motorcycle brakes, motorcycle tires and wheels and automotive parts. But then it's a solution that is like newly started. So then there are issues about like how do you place different components together in a very, very fresh industry.
So coming from the world of audio, I've always been interested in how sound can be used to communicate information. I mean, we use sound in our everyday life anyways as a means of feedback. If you think about when you're driving a car, for example, and you hear a weird noise and you know something's wrong with it.
One driver comes in and tells us, you know, I heard this sound from maybe this part, but I don't know where it's coming from. It sounds so bad. It's everything extremely subjective and not organized learning in any way.
The goal of this pilot project is to capture the sounds of these bikes, you know, and understand the sort of sonic characteristics of these vehicles, but not just to understand what they sound like, but to understand how we can analyze the sounds.
Interesting things to monitor, like different kind of road surfaces in general. And then when it comes to the bike, as I said, drivetrain, frame, and the front part.
So during this week, we took apart the bikes. We had a meeting with the engineer who developed these bikes and helped to design them.
The optimal scenario for us would be that several piezo kind of sensors strategically placed on the bike, so you can see from the different kind of sections and so on from. And together with all of the data, we can get quite a clear picture of what to input in the dynamic load test in the software to see the longevity, metal fatigue over time, and so on. How many oscillation cycles, how many times can a bike go over a certain bump, and before it becomes an issue, for instance.
So in the morning, I turned on the recorder and I pressed record.
So once we had collected a few hours of usable data, we separated all the audio files into different categories. We had categories that were more related to the bike components, so the actual bike parts, but also sounds that came from the environment around it. So that includes obviously the surface that it rides on. Once we had separated all the audio files into these categories, we converted the audio into images, into spectrogram images, and that's basically a visual representation of sound over time. And it's kind of like a signature of a sound that the machine learning model can identify, which will say that this sound is of that sounds category.
This project can be extremely helpful for us because it helps us to categorize and to rationalize and to have a method that will give us some order, if you will. it can be very helpful for us in knowing ahead of time when a problem is starting, and this is through monitoring, and this monitoring of the noises can be extremely useful because it will avoid a bigger repair that we have to do later on, which will cost more time and more money than if we had anticipated by monitoring.
So what we did over the last week is just one use case of how you can use this methodology, this combination of sound design and machine learning and engineering as well. I think we're interested in seeing how else it can be used, for what other purposes. And so now we want to put this methodology out there for other people to use and tweak and find a use for it.